suppose there is a capacitor. And having a capacitance C is attached to a battery of a potential V. So once the capacitor is fully charged, then we will have or fully charged,
Q equal to C.
we will have Q is equal to CV. Now detach the battery. Okay. After detaching the battery, let us examine what is happening. I have a charge Q and capacitance C.
The potential V remains the same across two capacitors.
Correct. So let the area of each plate be A.
Yes, sir.
Let the initial distance between the plates be D. And now what we are doing is we are pulling the plates from either side. We are pulling the plates from either side, and let us say I have changed its distance to D1.
Yes, sir. The area also will change. Okay.
Plate
And
area
also the
cannot
plates.
change because it
Yes.
is already manufactured, but distance between plates is something that I can maintain or manage.
Yes,
First of
sir.
all, while he is pulling the plates, okay, so there is a force applied.
Attraction between the two plates.
Correct. So my question was exactly that. Will there be a resistance for the force that is being applied or not? But there is a force of attraction between the plates, therefore there will be resistance.
Resistance here means that
Not the current electricity resistance. I'm saying there will be resistance against this force. It
like
is
there will be something to stop it like that.
that means if I'm trying to pull this, it's not like it is going to come easy,
Yes, sir.
right?
Yes, sir.
So basically, there will be some kind of a stoppage for the plates to go away from each other. Therefore, I'll have to apply some kind of a force. Clear?
Yes, sir. Yes, sir.
First thing is, what is the potential energy of this capacitor? Potential energy I can say is half CV square, or I can say it is Q square by 2C, right?
Yes, sir.
Why I'm writing it in terms of Q is because the charge is same,
Yes, sir.
right? And once I have detached the battery, this basically what we are doing here is detaching the battery, right? Once I'm detaching the battery, I cannot, I don't want to talk in terms of potential difference.
Yes, sir. I mean, both are constant, the charge and also the potential.
We will see, we don't know still yet. I mean, both are constant, but we will learn something probably. We don't know what is constant, what is not constant.
Yes, sir.
I only know that I am detaching battery. Because I'm detaching battery, I don't want to talk in terms of V, because there is no story of V over here. Maybe it is same, maybe it's not same. But Q, I know charge on the capacitor is Q. And I can talk of capacitance because I'm talking of area and distance between them.
Yes, sir.
Now, what is capacitance? Capacitance is epsilon naught A by D. Correct?
Yes, sir.
So if I substitute this fellow in the above equation, my potential energy will be half Q square. C is in the denominator. So epsilon naught A by D. Is this clear?
Yes, sir.
Now, this force when I am applying,
That is external force, so should it be minus? I mean, the sign convention thing.
slowly, that much I'm not fast. When you are saying plus or minus, for force you are saying, right?
Yes, sir.
Force is a vector, and when you talk of plus or minus in terms of vectors, that means you're talking of sign convention, right?
Yes, sir.
So tell me, what do I mean by sign convention or plus or minus over here? You're saying if I keep this as I cap, that is minus I cap.
No, not like. I mean, energies we talk like energy lost, energy gained, and all, sir.
That also I don't know. You're right. That also I don't know. I will learn.
Okay.
That is correct what you said. Energy, is it increasing or decreasing? I still don't know. But anything regarding force you want to say?
We have to apply equal amount of force on both.
It automatically comes out to be equal. It cannot be equal also. That fellow can be F1, this fellow can be F2. But usually if I'm using same mechanism, then automatically it comes out as a tension force, and force on either side will become equal. But you're right, I should also assume that the force on either side has same magnitudes. It is not necessary to be having same magnitudes. That fellow can have an independent source to apply force, and this fellow can have an independent source to apply force. In that case, F1 and F2 will be different.
Yes, sir.
So we are assuming that the forces that are applied on either side is zero. I am also assuming that I am keeping my kinetic energy, okay, also negligible. The previous small charge from
We wanted only potential energy.
Because I am interested only in potential energy. Okay.
Yes, sir.
So now I have potential energy as half Q square D by epsilon naught. Epsilon naught is anyways a constant. A is the area of each plate.
Yes, sir.
Charge on the plates, will it be a constant or will it be a variable?
It should be a constant, but then when they're going like far apart from each other, maybe I don't know.
But I am interested in the first half. You're saying it should be constant, but you should also explain why, right? We will go for but later.
Force of attraction, sir.
No, it should be constant, but you said. Why do you think it should be constant if for in any?
Because the potential difference is same.
Because the potential difference is same. Okay. I always tell to think in terms of layman terms, right? Okay, but now next second part of the statement is you said
If they like the plates are far apart from each other, there is no force of attraction, so there might be chances
for the charges to go back and restore.
Yes, sir.
But that only happens when the plates go at infinite distance. Otherwise, anywhere you will have kq square by r square as the force, right? That force
Yes,
becomes
sir.
electrostatic
I
force.
mean, field will reduce between them.
Field is kq by r square. The only distance where my field or force will be zero is when r tends to infinity, mathematically.
Yes, sir.
So, and infinity is not defined, at least right now. So, I would say the charges will remain same.
Sir, the capacitor is same only, so where will the charge?
Capacitor is the same only means what?
I mean, the capacitance is same only.
Who said the
Like,
capacitance is same?
I mean, sir, I
When
mean that.
distance is varying, can I say capacitance is the same?
But then if we consider that as some closed box or something, where can the charges run, sir?
Good point. When we consider it a,
Closed thing,
okay,
where can the charges run?
it's actually ulta statement. If I consider and if I actually look at it, not even consider, if I physically have a look at it, it is not a closed circuit, therefore where will the charges run? Not a closed circuit, therefore where will the charges? If it is a closed circuit, then charges will run. I told you mass requires free space to move, whereas charges requires continuous material medium for flow, right? So, ulta, if it would have been a closed circuit, then the charges would flow. Because it's not a closed circuit, it is cut from both ends and it's basically there is no
Yes, sir.
passage for charges to flow. Therefore, the Q is same.
Yes, sir.
So my observation is no charges can flow. No charges can flow. Therefore, my Q is constant. But my capacitance is not constant. Because epsilon not A by B. Right?
Yes, sir.
We will come over there. There is stuff to be done over there. But first, let me finish this point. I am saying assuming kinetic energy is negligible, that means I am only interested in potential energy is a function of D.
Yes, sir.
Therefore, the force F, suppose this is force F that I am applying on either sides. Therefore, the force F, I can write it as minus du by dt, right?
I don't know that.
F is equal to minus du by dr. We have written this earlier in previous.
Okay. Sir, I don't know how it came, but I know that exists.
That's fine. Right now you're on maths and chemistry, so it's okay. See, it's simple to tell because how can I write this is basically
Oh wait,
work
sir,
by
I understood, sir. Work done equal to like
FDR, work is minus d.
Yes, sir, but
And that's why I'm keeping kinetic energy negligible so that my work is completely minus du. Why is minus du? Because subscript story we said,
I understood, sir.
right?
Yeah.
Therefore, here I have distance as d, therefore I am writing dd. Anyways, when I differentiate this, I'll only be remain with q square by 2 epsilon naught e. This is the force that I have to apply. This is first thing that I have solved. Okay.
Yes, sir.
Clear? Now,
Yes, sir.
moving ahead, my charges will remain a constant, but my capacitance is not a constant because the distance is not a constant. Therefore, but I have to maintain Q is equal to CV equation. This I have to maintain. Therefore, Q is a constant, but C into V is not a constant. is a constant, sorry. Correct?
Then
Q is
we know that C isn't a constant, so obviously
obviously V is not a constant, so my
V should be constant.
no. I'm right, I'm coming. Let's go. Q is a constant. Therefore, my C into V is a constant. But my C is not a constant.
So V should be constant.
Right? I'm coming. At first, I'm not fast. C into V is a constant, correct?
Yes, sir.
But C is not a constant.
Hmm.
Even though, let me write V as Q by C, where Q is a constant. V is Q by C, where Q
That
is a...
is fine, sir. But then
Whereas C is not a constant, Q is a constant, C is not a constant. Will V be a constant or not a constant?
it should not be a constant.
It's like y is equal to 3 by x.
Hmm.
Right? When x is not a constant, y is also not a constant. So my potential difference across the capacitor.
Like to make that entire thing constant, like if C is varying, I mean V also should vary accordingly to make it constant.
To make the product constant.
Yes, sir.
Because charges has to be constant, but charges will be constant due to layman terms because there is no place for the charges to run away.
Yes, sir.
Okay, no passage for charges to run away. Next. So V is equal to Q by C. I know that my potential difference across the capacitor is not a constant, correct?
Yes, sir.
What is the... we have taken this from a distance d to d1, right? What is the final potential energy? Initial potential energy is this, right? Or you can say this, whatever.
Yes, sir.
My final potential energy, charge will be the same. Capacitance will be something C1. Therefore, my Q square by 2 epsilon naught A d1.
Yes, sir.
Okay, I have my final potential energy and initial potential energy. Wait, 1 second. Initial potential energy is Q square D by 2 epsilon naught A. My final potential energy. This is potential energy of capacitor of the charges on the capacitor. Remember, this is potential. That means this is the energy saved inside the capacitor, right?
Yes, sir.
Potential energy of a capacitor means the energy that the capacitance has right now. Capacitor has right now.
Yes, sir.
Is the initial potential energy greater than final or final greater than initial?
Sir, capacitance like later it is more, so potential difference will be less.
Again, think of things in terms of layman rather than making physics up. Simply D is only the thing that is changing. Everything else is constant. My D1, is it greater than D is all I have to check. If D1 is greater than D, my final is greater than initial. Right?
Yes, sir.
I don't have to think of if capacitance is more or not. That
Yes, sir.
that thinking is fine, but I might get confused if I think of it that way. Why? Because capacitance is basically how much charge can be stored. Q is equal to CV, right? C is equal to Q by V. how much charge will be stored if I give a potential difference of V. But here capacitance itself is
Well,
changed.
there also the deciding factor is distance only, sir.
Yes, epsilon naught A by D. So simply what I am saying is, looking in terms of layman terms will make things very easy compared to if I think of in terms of if the capacitance is increasing or decreasing and the
Yes.
energy. That will make more confusion. That's the reason we are writing these equations in this form. Otherwise, without
Yes.
writing equations also we can just discuss, right? But that will be confusing, remember. I don't want to confuse you right now. It is very easy to confuse over here. Very easy.
Yes,
Okay.
sir.
Simply what we are saying is I am writing the potential energy. Initially
Well,
also.
by the way, there is a minus symbol in the force thing, so you have to put minus.
Yeah, I mean we were interested only in the magnitude, that's why I left it like that.
Okay, okay.
That's why
We
here
leave it
also
like
I
that.
did not wait then, because in terms of force my minus sign is only telling me the opposite direction. But both sides force I am knowing that it is F.
Yes, sir.
My final potential energy is greater than initial potential energy. Because my D1 is greater than D implies my final potential energy is greater than initial potential. So is the energy added to the system or is the energy taken out of the system?
Potential energy is added.
Because final is greater than initial.
Yes,
If it
sir.
was 50 laddus, now it is 100 laddus. I have given 50 laddus. Only that situation, the potential energy basically is more, right? That means
Yes, sir.
we have added the energy to the system, right? Final
Yes, sir.
potential energy is greater than initial potential energy. Initially there were 50 laddus. Now I have added further 50 laddus. Therefore, it is final is 100 and 100 greater than 50. That means I have worked on the system.
Like we have given energy.
We have given energy to the system, or I can say work is done on the system. This word is
Yes.
important. On. It is not work is done
By the forces.
by the forces, right? Also, other way, layman way of looking at the same thing is that obviously I am applying some force for this capacitor to, plates to go away
Yes.
from each other. That means somebody is working on it. If
Yes, sir.
if work is done by the system, why will I require this force? System will
Well,
only
it's
push.
like I mean, the external agent like is losing the energy. That means that like for conservation, he have to like give the energy to the system. Like he is losing the energy, so the system should store it.
Repeat.
So like when the external agent is working, like definitely the external agent will lose energy. Like if it loses energy, that energy should go back to the system because of the conservation of energy there. Is it wrong?
Who is losing energy?
They're the external agent.
Okay.
If external agent is losing energy,
That means he is losing it to someone or
yes,
something.
there's only the system over it.
So
I
there
mean,
is only system present other than the external agent.
yes, sir.
Therefore, the system is basically receiving the energy. Yes. Okay. So now, how much is the work done?
The no initial minus.
Final minus initial. I don't have to fight it out because uh, if I think of it in terms of laddus, there were 30 laddus initially. I gave 40 more laddus, total 70 laddus. So
Yes,
how
sir.
many laddus did I give? Final minus initial, 70 minus 30. Taylor story. Okay, right? So simply everything else is common. D1 minus D only we will get, right?
Yes, sir.
Is this clear?
Yes, sir.
Xerox. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.